In this webcast, we're going to talk about projectile motion and how you find the position of a particle that's been fired from the origin at an initial speed of v0 with an angle of alpha. How do you find its position at any time t? The key things is the velocity at time t is the derivative of the position, and the acceleration at time t is the derivative, or the second derivative of the position, or the derivative of the velocity. Some key things we're going to note with is start with an assumption that the only acceleration is due to gravity, and that it is constant, being 0, negative g, where g is either 32 feet per second squared, or 9.8, or 9.81 meters per second squared. If you know the acceleration and you want to find the position, then all you have to do is, well, velocity is the integral of the acceleration. So if you want to integrate a vector, then you integrate each component. The integral of 0 is 0 plus some arbitrary constant. The integral of minus g is minus gt plus another constant. I'm going to name them c1 and c2 to keep them separate. The position is the integral of the velocity. So I integrate this term here. I'm going to integrate c1 negative gt plus c2. Doing so gives me c1t plus another constant, call it c3, and negative gt squared over 2, plus c2t plus another constant. At this point, we need to know what are these constants. And that comes from looking way back up at the beginning. At the beginning, we knew that the position at time 0 was 0, 0. We also knew that the velocity at time 0 has to do with this vector. We're going to take that vector, v0, alpha, and we're going to write it in terms of its x component and its y component, where vx0 is v0 cosine alpha. Basically, we're using polar coordinates, and vy0 is v0 sine alpha. So using that information, I know that the velocity at time 0 is vx0, vy0. But I also know I can put 0 into this equation, giving me c1, comma, minus 0 plus c2, which means that c1 is vx0 and c2 is vy0. Similarly, I know that I can put 0 into the position to get out 0, 0. Or I can put 0 into the position equation and get out c3, and that's 0, 0, c4, which means c3 is 0 and c4 is 0. In summary, this means that the velocity at time t is c1, which is vx0, negative gt, plus c2, and c2 was vy0. Similarly, the position at any time t is, well, c1, which we discovered is vx0 times t, plus c3, which is 0, so I can get rid of both of those. They're both 0. Then I have a negative gt squared over 2, plus c2 was vy0 times t plus 0. These are our key equations that we're going to use to talk about projectile motion. That ends this webcast.